Today I will demonstrate about the experiment how to measure the magnetoresistance of a sample. So, resistance of a sample we are used to measure. How to measure? Just it is a basically Ohm's law, verification Ohm's law. You know, if you take a resistor, now we pass current through the sample and measure the voltage drop across the sample. Okay. So, resistance is the voltage drop across the sample divided by current passing through the sample. So, now this resistance, it responds, it varies with external parameter like magnetic field, temperature, pressure. So, today we would like to see how resistance depends on the magnetic field. So, that resistance depends on the magnetic field that we express in terms of magnetoresistance. So, magnetoresistance is a phenomenon in which the electrical resistivity of a material changes in the presence of external magnetic field. So, this phenomenon was observed or discovered in 1956 by Lord Kelvin. He is also his name is basically William Thomson, but he is known to us as a Lord Kelvin. So, magnetoresistance is defined by this RH minus R0 divided by R0. So, RH is basically resistance at R0 is resistance at H equal to 0, magnetic field when magnetic field 0, and RH is resistance at H is not equal to 0, means in presence of magnetic field. So, to know the magnetoresistance, we have to measure the resistance of the sample without magnetic field and then resistance of the sample in presence of magnetic field, and then using this formula we can calculate the magnetoresistance. So, now basically we define the magnetoresistance in two ways. One is called transverse magnetoresistance, another is called longitudinal magnetoresistance. When magnetic field is applied perpendicular to the current, sample current, then that is called transverse magnetoresistance. When magnetic field is applied parallel to the current, then the magnetoresistance is called longitudinal magnetoresistance. Now, for a small field, the transverse magnetoresistance for semiconductor can be written as this magnetoresistance RH minus R0 divided by R0 is proportional to H square. Okay. So, theoretically one can find out this, that for small field and for semiconductor the magnetoresistance depends on magnetic field. How it depends? Whether it is linearly proportional or it is proportional to the square of the magnetic field. Okay. For metal, it will not be this, dependence will not be this, it will be different. So, our task is in this laboratory we will use semiconductor, germanium semiconductor and n-type germanium semiconductor, and we will measure the magnetic resistance of that sample at different magnetic field. Then we will plot the magnetic resistance as a function of magnetic field, and we will verify the dependence of this magnetic resistance on magnetic field. So, that data we will get whether we can fit this with this expression. So, that curve it should be parabolic curve, because y equal to x square kind of formula expression here. So, if we are expecting that this data, if we plot that graph, it should be parabolic. Okay. So, theoretically it is found that this type of dependence of magnetic resistance on magnetic field for semiconductor in transverse mode. So, from this experiment in this laboratory, we will verify this, this expression. So, for this experiment, what we need? We need basically constant current source. For sample current, we will apply constant current in the sample, okay, and then we will measure the voltage drop across the sample. So, we need voltmeter, we will use nanovoltmeter or microvoltmeter. Then we need basically magnetic field. So, how to generate magnetic field in laboratory using the electromagnet that I have discussed. Then we need Gauss meter to measure the magnetic field, and we need basically connection for passing current through the sample. We need connection with the sample. Also, we need connection with the sample for measuring the voltage drop across the sample. Okay. So, we are used to make connection for electrical measurement. We use wire and just we connect different component using the wire. So, sample, and you have different meters, voltmeter or ammeter or Gauss meter. Okay. So, what I would like to tell you that for electrical measurement, generally whatever the way we measure in the laboratory, so that we call the two probe method or two connection method, but for this experiment we will use 4 probe method. So, what is 2 probe method and what is 4 probe method? Why we will use 4 probe method? Whether 4 probe method is better than the 2 probe method. So, that one should know. So, that let me discuss this 4 probe versus 2 probe method. So, this This 4-probe method is used for electrical characterization for this experiment. So, why? Why we will use 4-probe method? Why not conventional 2-probe method or 2-connection method we will use? So, let me tell you what is the difference between these two methods and how this 4-probe method is better than the 2-probe method. So, this is this red one, this is your sample, this is your sample. So, with sample you need to connection 2 electrode, okay, for passing current through the sample. So, let me take this. So, just you have to take 2 contact with this sample. So, this red 2 line. So, with some wire you have to make contact either using silver paste or whatever the way. So, you have to electrically make connection with this sample. So, these 2 points from where this wire is, either one can solder also. So, these 2 wire we are taking out. So, we have connection with the sample at these 2 points. Now, this is the constant current source. Now, this constant current source is connected with these 2 contact, and for measuring the voltage, again that voltmeter we have connected across this sample. So, using the same connection, we can connect the voltmeter like this. Okay. So, basically here with sample there are two contact, one is here, another is here, and using these 2 contact we are connecting the constant current source as well as the voltmeter, right. So, now we will apply constant current, some current. So, current will pass through it either this in this direction or this direction. So, it will pass through the sample. So, since it is constant current source, so constant current will pass through this sample. Fine. Now, this voltmeter will give me reading voltage which drop across the resistance between these 2 points, because current is flowing. So, when current is flowing, so wherever it will see the resistance, there will be voltage drop. Okay. So, here RW I have written, that is this wire resistance, from so voltmeter basically it will give the reading, the voltage drop across the resistance wherever present in this circuit, right. So, it will see the voltage drop basically across this resistance, then RC basically this contact resistance. So, similarly the other side also RC and RW, and this sample resistance is R between these 2 points. So, this voltmeter, whatever the reading it will give, basically that voltage drop across the total resistance. So, what will be the total resistance? 2 RW plus 2 RC plus R. Okay. So, that will be the total resistance, and voltmeter will give the voltage, the reading, that is V divided by this constant current will give us this reading of current passing through the resistance, So, that is I. So, basically we just connect and we take reading of voltmeter and ammeter from current source. So, now just we divided this V voltmeter reading divided by this current reading from the constant current source. So, V by I is resistance. So, that resistance is basically R total. In R total, what is there? This contact resistance as well as the wire resistance, both are present along with the sample resistance. So, this we tell generally two probe method, means we are using two contact for the electrical measurement, and in this measurement you can see we cannot get the only R value, this R value along with the other contact and wire resistance. Now, when the sample resistance is very high, then this contact resistance and wire resistance may be negligible. So, in that case one can use this two probe method, but if sample resistance is not very high, okay. So, if it is small value, if you use metal semiconductor, N-type semiconductor we will use in a laboratory, so their resistance is not very high. So, in that case this contact resistance and wire resistance may be comparable to the sample resistance. So, two probe method we cannot use in this case. So, to avoid whether there is any way out to this contact resistance in the measurement. So, let us see. So, that is the purpose. So, how it is done in the using the 4 probe method. So, here we tell linear 4 probe method. Okay. So, this 4 contact will be taken from the sample and they are linear. So, that is why it is called linear 4 probe method. There are other method, Van der Pau method. Okay. That I will not discuss. So, here, so same sample, so only here 4 contact we have taken from the sample. So, this outer two contact is used for the current, for applying current, passing current through the sample, and middle two contact is used to connect the voltmeter. So, in this method we are telling that you can avoid the contact and wire resistance. Only in this case you can measure the sample resistance. So, how? So, here, people can think that in this case 2 contact, whereas here it is 4 contact. So, there will be more contact resistance. So, how it is better? How it is better than this 2 probe method? So, here you see that constant current is passing through this wire and then contact, then sample. Okay. So, same way as it is happening here. So, now look at the measurement of voltage. We have taken the connection between these 2 points. Now, voltage drop across the resistance. Here, what is the resistance? Wire resistance. So, there will be voltage drop across this resistance, across the contact, this contact resistance, but it will not be, because this voltmeter now it is not connected this way, it is directly connected to the sample. Okay. So, this wire resistance and this contact resistance will not come in this voltage drop. So, but there are two more contactors there here from where we are taking the connection for the voltmeter. Now, here if there is no current passing through the contact, then there will not be voltage drop and it will not be included. If current passes through the contact, then there will be voltage drop. Now, when current is coming here, so current has two paths, one is this path through the voltmeter and another is through the sample, Now, here voltmeter, that you know the resistance is very high, no current pass through the voltmeter, it is so very high resistance of this voltmeter. So, when it will come here, no current will pass through the voltmeter. So, whole current will pass through this sample. Okay. So, if there is any current passing through the voltmeter, so it has to go through this contact, but current passing through the sample do not need to go through this contact, it will go through the sample. Okay. So, no current will pass through the voltmeter or negligible current will pass through the voltmeter. So, voltage drop, there will not be voltage drop or negligible voltage drop due to this contact, okay, or this wire. So, that one can neglect it because of very high resistance of the voltmeter compared to the sample resistance. So, it is expected that whole current I will pass through the sample. So, voltage drop across the resistance between these 2 points of the sample, that is R. So, you will measure the resistance of this using this formula, whatever voltmeter reading you are getting V and whatever current you are getting from your constant current source. So, V by I equal to whatever resistance you will get, that is purely sample resistance. So, this is the 4-probe method and which is superior to the 2-probe method, and this method has to be used when you are going to measure the resistance of metal or semiconductor. If any insulating material, in that case, or resistance is very large, in that case 2-probe method is used. Generally, so far you have used this probably 2-probe method for different electrical characterization. In case of Ohm's law verification in class 12, 11, 12 or class 10, you have done that experiment. So, there the way you have measured, that is called 2-probe method. But in this case, we will use 4-probe method, and 4-probe method is superior to the 2-probe method. So, one should understand this method clearly. Okay. So, we will use this 4-probe method for measuring the electrical characterization in this laboratory. So, what we have to do? So, experimental data collection. So, first magnetic field versus coil current calibration for a particular air gap between the pole pieces. So, electromagnet, you know already, I have discussed. So, there are between pole piece there is a air gap, and in that air gap we will place our sample for magnetic field. Okay. Now, this magnetic field strongly depends on the air gap. So, we have to fix the air gap. That air gap, it should be such that you have to place sample in that gap. So, gap should be sufficiently large, or it should be comparable to the size of the sample with the probe connection. Okay. So, you have to fix the air gap between the pole pieces of the electromagnet, and now in this condition we have to calibrate the magnetic field versus coil current. Coil current means the current we are passing through the coil of the electromagnet. So, for different current, what is the magnetic field, that we will measure using the Gauss meter, Hall probe, and that will plot in graph paper magnetic field versus the current, and that graph will use as a calibration curve for magnetic field, because when we will do experiment we have to put sample between the pole piece. So, there we will not put the Hall probe for knowing the magnetic field, because it can disturb, it can affect the measurement of the resistance. So, we will not use the Hall probe or Gauss meter during the electrical measurement. So, that is why before starting the measurement, this resistance measurement using the 4 probe, we will calibrate the magnetic field or calibrate the magnet. That means magnetic field for different magnetic this coil current for a particular air gap. So, that is the first job task we have to do, and for that I have not shown here table. So, one has to make table. Basically, we have to write what is the air gap, that we should note down, and then for that air gap what is the current versus magnetic field. Okay. So, for different current we will take, and this for different magnetic field we will note down from the Gauss meter, and then that table will be used for drawing the graph, and that is the calibration curve. Now, after calibration we will place our sample, we will make 4 connection using the 4 probe method, and with this 4 probe connection we will place the sample between the pole piece, and then we will do experiment. We will take data. What data we will take? That sample current, at different sample current we will do the experiment. So, we will fix a particular current, sample current. Now, for that sample current, now we will apply, we will vary the coil current, means we will vary the magnetic field. So, for 0 magnetic field, what is the voltage? Then how voltage will vary with the coil current. So, we will take data for a particular sample current, what is the voltage across the sample for different coil current, that we will note down. And we can keep another column after the coil current, that is magnetic field. From that calibration curve one can find out the magnetic field from this current. So, basically you are getting data magnetic field versus voltage. Okay. Now, current, for that current different voltage you will get, different for different magnetic field, corresponding resistance you can calculate V by I. V by I you can calculate the resistance. Okay. So, for 0 magnetic field, that is R0, fine. So, now that you will get RH for different magnetic field. Now, you can calculate the MR, magnetoresistance for different magnetic field. Okay. So, now we will draw graph, next we will draw graph magnetoresistance versus magnetic field. Okay. And then we will verify whether we are getting the curve, this parabolic curve or not. If you get parabolic curve, whether you are getting linear curve or parabolic curve, or it is fitting with some other parameters. So, here we will verify MR is proportional to, here I have written B, so one can write B also, but as I told H, so I will write basically H square or B square also, then I have to write at all places B. Okay. So, that is the experiment I will demonstrate after this discussion. So, let me stop here and then go to the experimental setup to do the experiment. Thank you.